In this video, we are going to be talking about scientific notation. So sometimes in math, you will have to work with very large numbers. So for example, the distance between the Earth and the Sun is 92 million miles. How many seconds are there in 70 years? Is a really big number as well. Same as how many years ago dinosaurs roamed the earth, and so on. And so we need a way to write them so that they're easier to use in math. Well, if we use our knowledge of powers, we can use this to help us. So 10 is 10 to the power of 1. 100 is 10 times 10, or 10 to the power of 2. Because remember, powers tell us how many times that number is multiplied by itself. So 1,000, which is 10 times 10 times 10, then becomes 10 to the power of 3, and so on. And so we can use our knowledge of powers to help us out here. Now note, on a calculator, you may see it as e to 6, and what it means is times 10 to the power of 6. We can apply this to numbers other than 100, 1,000, 10,000, and so on. So 200 we can write as just 2 times 100, or 2 times 10 to the power of 2. 4,000 we can write as 4 times 1,000, or 4 times 10 to the power of 3, and so on. And this is known as scientific notation, taking a number and writing it as a power of 10. So I want you to try, take these 3 numbers and write them in scientific notation with a power of 10. So pause the video, write it out, and start it up again when you're ready. Okay, so 2,000 we can write as 2 times 1,000, or 2 times 10 to the power of 3. 20,000 we can write as 2 times 10,000, or 2 times 10 to the power of 4. And 9 million we can write as 9 times a million, or 9 times 10 to the power of 6. So in other words, how do we do this, especially if the number isn't so nice as 8 million or something, there's some other numbers in there. What is the actual method or strategy for writing a number in scientific notation? Well, what we do is we look at where the decimal point is in the number, and we look at where we can place that decimal point so that the number is between 1 and 10, or less than 10. So in this case, if I move the decimal point 1, 2, 3, 4, 5, 6 times and put it right there, then that means I have a number 8. And so we want to move it until we get to a number between 1 and 10. So bigger than 1, smaller than 10. And we're going to count how many jumps we made. So again, I made 6 jumps to get there. So it becomes 8 times 10 to the power of 6. And so that first number must be between 1 and 10. And the power tells us how many times we move the decimal place. So again, if I'm looking at this number, I want to see where I can place that decimal point to get a number between 1 and 10. And I see I can place it right here between the 9 and 2 to get 9.2. So if this is where my decimal point is, I'm going to move it 1, 2, 3, 4, 5, 6, 7 times. And so to write it in scientific notation, we get 9.2 times 10 to the power of 7. In other words, I would have to times 9.2 by 10 7 times to get back to its original number. So again, this first number is between 1 and 10, and the 7 is how many times I moved the decimal place, or how many times I would have to multiply by 10 to get back to my original number. So I want you to try this one. Pause the video, write it in scientific notation, and then start it up again when you're ready. And so I want to move the decimal point right here. So I'm going to count how many times I need to move the decimal point to get there. I get 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we get 2.2 times 10 to the power of 9. And one more. I'm going to move the decimal point right here to get 2.28. And some people think I'm going to move it there because we're used to seeing just one number. But actually that gives me 22, which is bigger than 10. So I'm going to have to place it right here to get a number between 1 and 10. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 times. So 2.28 times 10 to the power of 8 is how long ago dinosaurs roamed the earth. Okay, so I want you to try these ones. Pause the video, start it up again when you're ready. Okay, and here are our answers. Okay, so how do we go the other way? I have a number in scientific notation. I want to write it out in full. What we're going to do is look at the power next to the 10, and that is going to tell me how many times I'm going to times my number by 10 or move the decimal place to the right. And so what I like to do is I write my number down and I write a bunch of zeros to give myself some space, and then I kind of count over, in this case, 7 times. So 1, 2, 3, 4, 5, 6, 7. So my decimal point is going to move right there. And then I can cross out any extra zeros that I wrote, and I get my final answer. Okay, so again, let's try for this one. I'm going to write my number, add a bunch of zeros. In this case, I'm going to move it 5 places. So 1, 2, 3, 4, 5. And then cancel out any extra zeros that I wrote, and I get 346,000. Okay, so I want you to try these ones. Again, pause the video, start it up again when you're ready. Okay, and here are our answers. Take a second to check your work. Pause the video if you need to. Okay, so what about really, really small numbers? Because sometimes, specifically in science and health, you may have some medications, for example, that are very, very small doses. And so we also have to work with really, really small numbers, such as the width of an atom. Look at how small that number is. So we have to find a nicer way to work with this. All those zeros, we're going to miss one, which will come up with a medication error, which is not good. So if we are wanting to work with this number, we need to have a better way, and we can use scientific notation for that as well. So for example, here is our number. Same process applies in the sense that I want to move the decimal point so that I get a number that is bigger than 1, so between 1 and 10. So in this case, I'm going to move it all the way on this side of the 1. So I'm going to count how many times I move it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times to move the decimal place so that my number is between 1 and 10. Now, how do we differentiate between moving the decimal place to the right versus moving it to the left? Well, in this case, to get back to my original number, I'm not multiplying by 10, I'm dividing by 10. And so we are going to use a negative power here in order to represent the fact that I'm dividing by 10 instead of multiplying by 10. So we're going to use negative sign there to show that it's going to get smaller, that the number is going to get smaller rather than bigger when we go back out. Okay, so it's the same process. The only difference is you're going to put a negative here to represent the fact that the number is a small number. And so that becomes obviously a much nicer and easier number to work with than trying to make sure that you include all the right number of zeros. So let's try this one. Again, I want to move the decimal point to get a number between 1 and 10. So in this case, I'm putting it right here between the 7 and 6. So let's count 1, 2, 3, 4, 5, 6, 7 spots. So I get 7.6 times 10 to the power of negative 7. Again, we're using the negative because it's a small number. Right, in this one, I'm going to move the decimal point between the 1 and the 9. So I get 1.93. If I move it here, I get 19, which is bigger than 10. And if I put it here, I get 0.1, so that's smaller than 1. So I'm going to move it right here. So I get 1, 2, 3, 4, 5, 6 spaces. So I get 1.93 times 10 to the negative 6. Okay, so I want you to try these ones. Pause the video, try them out, and start it up again when you're ready. And here are our answers. You can check your work, pause the video if you need to. So let's look at how we go back. So I have the number in scientific notation. I want to write it out as its original number. And I'm noting that there's a negative here, which means my number is going to get smaller. I'm actually dividing by 10 3 times instead of multiplying. So I put my number down, but this time I'm going to put zeros in front of my number. And I'm going to count 3 spaces. Remember, the decimal point's behind the 2. And I move it 3 spaces, 1, 2, 3. And so I end up with 0.002. Now, I always encourage people to put a 0 in front of the decimal place, especially in the medical field or even in the trades where you're writing on blueprints and things like that. It's very easy to miss this little decimal point, and you don't want them to think that the number is 2 or something that could cause a lot of problems. And so I always encourage people to add this 0 here so that it's harder to miss that decimal point there. It's just good notation and a good habit to get into. So don't forget that 0 in front. Okay, so let's look at this one. Again, the negative 5 tells me I'm moving to the left. So I'm going to put my number down, write some zeros in front of it, and move 5 times. 1, 2, 3, 4, 5. And so I get this as my number. One more time, I'm going to write my number down, put some zeros in front, and in this case, I'm moving it 6 spaces. So 1, 2, 3, 4, 5, 6. And I get my number. Okay, I want you to try these ones and pause the video, try them out, and start it again when you're ready. And here are our answers. You can pause the video to check your work. Okay, so I want you to reflect over how you have done throughout this video and rank yourself thumbs down if you're having some trouble with these and you need some help, a pointer if you need some more practice, and a thumbs up if you can solve these problems, you don't need any more help or practice.